Hey, David again here with another question from your Haysom Harris Math SL textbook. This is Chapter 6C.2, Question 1, Part A. We're meant to write the following quadratic equation in the form y equals x take h squared plus k. This is vertex form. And we're meant to make that transformation by completing the square. We'll then use the information we got from doing that process to state the function, to state the vertex and sketch the function. So first off, let's try completing the square to transform this. I see that x is inside this term here, so I'm going to try to complete the square. When I'm completing the square, I'm just going to make a little bit of room for what I'm going to add in. So I'm going to separate the constant term, and I'm going to add my own constant term to turn this into perfect squares. In perfect squares, I should be in the form a squared x squared plus 2abx plus b squared. From this I see that a has to be equal to 1 and 2 has to be equal to 2ab. Negative 2 has to be equal to 2ab, which means negative 1 has to equal ab, and since I know that a is equal to 1, b has to equal negative 1. So this means that y is equal to x squared take 2x, and to make perfect squares I'm going to insert a negative 1 squared. I still have my plus 3 on the side, and I need to also, to keep the equation balanced, subtract negative 1 squared. So I'll add negative 1 squared and subtract negative 1 squared simultaneously. Now this whole thing is perfect squares, so I can replace it with x take 1 squared, and then I have 3 take 1, which is 2. So now I'm in the form y equals x take h plus k. X take h squared plus k. In this vertex form, the vertex is just h comma k. So the vertex in this case is 1 comma 2. That'll help me get started sketching the function, but anytime I draw a sketch, I want to make sure that I have all of the key points. One of the key points is going to be the vertex, but the axes-intercepts are also going to be key points. So I'm going to try and find the y-intercept. And that occurs when x is equal to 0. So I'll get y equals x take 1 squared plus 2. That's 0 take 1 squared plus 2. Negative 1 squared is 1, plus 2 is 3. So my y-intercept is 3. X-intercepts occur when y is equal to 0. So I'll take y equals x take 1 squared plus 2, and I'll let y be equal to 0. And solve for x. Solving for x, I'll subtract 2 to the other side and take the square root. And what I get is the square root of negative 2, which has no real solution. Which means there are no x-intercepts in the real plane. That is enough information to sketch. So let's put down some axes. We'll put in our vertex at 1, 2. Our y-intercept was at 3. And we know there are no x-intercepts. The vertex is then going to be a minimum, and we'll get a quadratic that looks like this.